Hello good people, I'm going to talk about compound interest. It is the interest accumulated from a principal sum and the previously accumulated interest. Simple interest, on the other hand, is calculated based on the initial principal sum only. Most of the interest calculated in the financial world is actually compound interest. When we open a savings account or when we borrow money from a bank, the interest that is being calculated will be compound interest. Here is a problem for us to chew on. A person places $24,000 into a long-term savings account with an interest rate of 4.65% per annum. I know that you are all wondering where the money is coming from. Suffice it to say that not all dirty deeds are done dirt cheap. Anyway, the question is, what is the amount of money present in the account after 5 years if the interest is calculated daily? In order to solve this problem, we need the compound interest formula. It is A equals P multiplied by 1 plus psi, all of that raised to the power of n. A stands for the amount at the end of the investment term, P stands for the principal amount that we are going to invest initially, I stands for the interest rate for a calculation period, and n stands for the number of times interest is calculated. Let me apply this formula to our problem. The amount present in the account after 5 years is represented by A. That is what we are trying to calculate. P is the amount of money that we are initially going to invest, $24,000. I'm going to open the bracket and write 1 plus. Now I need to enter the interest rate. And here I have to watch out for a few things. The interest rate should be expressed as a decimal. It is given to us as a percentage. So 4.65% will become 0.0465. But that is not all. There are two very important pieces of information that are given to us regarding the interest rate. This 4.65% is per annum or per year. However, the interest will be calculated daily. This means that we need the daily interest rate, and we will get that by taking 4.65% and dividing it by the number of days in a year. And so over here in our formula, we will have a somewhat horribly looking fraction, 0.0465 over 365. Once I close the bracket, I need to raise it to the number of times that the interest is calculated. The interest is calculated daily over 5 years. So, how many days in 5 years? Well, it will be 5 times 365. Yes, I'm excluding leap years. Now that I have set this up, I'm going to ask the calculator to do the number crunching for me. I'm going to enter the principal. It will be multiplied by everything inside the bracket, and the entire bracket will be raised by 5 multiplied by 365. And the calculator tells me that it is $30,281.56. At this stage you might be wondering, fantastic, but why are we talking about compound interest in a module on logarithms? Time is the ultimate commodity, and so often the question is not how much money we will have, but how long before we have that money. Let me look at a different question. We are still dealing with the same person and the $24,000, and the interest is still 4.65% per annum. However, this time the question is, how long would it take for this person to end up with at least $36,000 in their account if the interest is calculated daily? In other words, we are asking about time. We start with the formula for the compound interest. We know that the amount at the end should be $36,000. The principal is still $24,000, and the contents of the bracket remain the same as before. So we will have 1 plus the interest rate, 0.0465 divided by 365. The unknown is n. We are trying to figure out how long before this 24,000 turns into 36,000. We need to do some transposing, and remember, we're going to do it in reverse order of Pedenza. And so I'm not going to touch this bracket or anything inside it, and I'm definitely not going to touch this power. However, this 24,000 is involved in a multiplication. I can transpose it by division. 36,000 divided by 24,000 will give me 1.5. On the right-hand side, I will be left with the bracket and the power. I cannot solve for the unknown so long as it is a power. And this is the moment where we need to introduce logarithms. I'm going to take log of both sides. And that will give me log 1.5 and log of this entire bracket. How is this helping us? We seem to have made things more complicated. True, but now that we have logs, we can use the log power rule. It will allow me to place this n in front of the logarithm. And so in the next line, I will have log 1.5 equals n multiplied by log of this entire bracket. From the point of view of the unknown, it is being multiplied by this entire horrible looking logarithm. However, there is a silver lining to all of this. In order to decouple this logarithm, all I need to do is perform the inverse of this multiplication. Both sides need to be divided by this complicated logarithm. And so we will have this nasty looking fraction, log 1.5 over log of 1 plus 0.0465 divided by 365. I'm going to go into fractional notation, and then I'm going to enter the log above the line. I'm going to move below the line and enter the log. Make sure to close the bracket and move the cursor to the right, and then press equal. And here we go. We have a result. I'm going to round it to the nearest whole day. And so we can say that it will take 3,183 days for the initial 24,000 to mature into $36,000. 3,183 days is a bit hard to imagine, so we could convert it into a number of years by dividing it by 365. According to my calculator, that is about 8.7 years. So start reading a thick book because it's going to take a while. That is all for now, and I will see you on the flip side.